Good morning, everyone. I'm Brock. So today, let's keep working on a LeetCode quiz question. Yesterday, I forgot to record my share my screen, so the recording only has my own face. So I hope that in the future I can remember to share the screen. Okay, so let's look at this question. This question is sum of numbers with units digital k. Given two integers lam and k, consider a set of positive integers with the following properties. The units digit of each integer is k. The sum of the integers is nam. Return the minimum possible size of such a site, or -1 if no such site exists. The site can contain multiple instances of the same integer, and the sum of an empty site is considered 0. The units digital of a number is the rightmost digit of the number. Okay, let's look at the 3 examples here. The first one is 58. The sum should be 58, and the unit number is 9. So we can find the site 949. So there are 2 elements in the site, so 2 will be the output. In the second example, the sum of the numbers are 37, and the unit digital of all numbers is 2. We cannot find such site, so the output is -1. And then in the third example, the sum of all numbers is 0, and the unit digital is 7. From my perspective, we cannot find such a site, but based on the description, empty site is acceptable, so the output is 0. Although I personally think for empty site, the condition k is equal to 7 is not satisfied. But anyway, okay, I think the goal is straightforward, right? So the basic idea, I think that we need to check special case, right? Lam is equal to 0. So let's write some basic ideas. Firstly, we need to check sum is equal to 0. Then, if we pick I numbers, each adding with digital k, their total units will be I multiple k mod 10. Make sense? So you choose I digital. Then the sum, well, the unit digital of sum will be I multiple k, right? Then we need to ensure that nam minus I multiple k is larger or equal to 0. And nam minus I multiple k can be divided by 0. So we can try I from 1 to 10 to find the smallest feasible I. And if we cannot find such an I in I to 10, then it's impossible. Oh. Make sense? Okay, based on these thoughts, I think that we can use some example to clarify our thoughts. So let's say number is to 7, is to 5. So step 1, right? We'll check whether number is 0. Obviously not. So we will continue. We go to step 2, right? So for step 2, we will try I from 1 to 10. Let's so if I is equal to 1, then number minus I multiple K is I multiple K num minus 5 is equal to, right? Invalid. Then let's try number I equal to 2. I multiple K is minus 3, obviously invalid. And then we need to increase I, right? Because it's always negative, which means that the num is too small. So no need to keep going. And yeah, because we cannot find anything, so we just say, okay, return -1. Right? Because we cannot find anything. So based on this test case, let's to check empty set first, right? So if lam is equal to 0, we just return 0. Make sense? Then we try to use, I numbers, which is from 1 to 10. So for I in range 1 to 11, we want to compute the remaining after remove I times K from a number, right? Just like here, we calculate the remaining I minus I multiple K. So if the remaining is negative, we cannot represent num with I positive, right? So if RAM is remaining smaller than 0, what does it mean? It means that we need to skip to next I, since the remaining must be non-negative. Make sense? And then we need to check the whether it can be divided by 10, right? So if it's divided by 10, then we can return I. Because if you look at the examples here, for example, we start from uh, 9, right? When we get 2 9, 2 multiple 9 is 18, right? And 18, we use 58 minus 18. What do we get? We get 40. And 40 means that, okay, the remaining is a non-positive, negative, right? And 40 can be divided by 10. That's good, right? So then we return 2. And if nothing works, then we just remain return -1, because if nothing in from 1 to 10 works, it's impossible to form such nums with such numbers. Make sense? I think that yeah, the process is super clear. Let's see. Oh yeah, I forgot to have a comma here. Outset of the function. Ah, I get it. It's, yeah. Okay, yeah. Indication. If we, I felt that it's very easy in Python because it's not like it's not like C++. We use brackets to to divide codes into blocks. It's very easy to have wrong indication. Let's submit it. Okay. Oh. Well. This runtime is amazing. It's really fast, huh? That's interesting. Well, yeah, because it's O1 complexity. And the memory is, yeah, it's also O1. Interesting. Yeah, so yeah, I think that I have tried, to write a LeetCode, in the past few days. And one of my reflection is that what is most important is not just get the question and start write codes. It doesn't work in this way. The first thing is that based on the examples, right? To summarize some observation. After we get some observation, then we can try to write a test case to go through. To work through our observation, right? And then the last step is to write codes. Code itself is just translate the natural language of our observation into, code. If we don't use, if we even cannot, clear our mind with natural language, I don't think that we can, write a clear code, right? So I guess there's some learning, from today's, LeetCode question. And I hope that I can keep, use this strategy. Well, I cannot guarantee, but let's try. Okay, thank you.